In this video I'm going to talk a little bit about soldering. There's been some comments from viewers asking questions about how to solder and if there's any good video out there, and I'm sure there's actually quite a few good videos out there about soldering. So mine's going to be very simple. I'm going to talk about some of the stuff that you might want to get or you might need depending on which type of soldering you're doing. And yeah, so let's get started with it. So if you see in front of you here, there's like an assortment of soldering irons, and you've got different soldering irons for different jobs. And with a large soldering iron like this is a 100-watt soldering iron. This is more intended for bus bar type work. So obviously you're not going to necessarily need this for home. This again is like intended for soldering electrodes, and this is a 75-watt soldering iron. This would be more what you would see typically for home use, and this is a 35-watt, although they do come in 25-watt sizes. And this is more of an industrial soldering iron, and it's temperature controlled. So this is, I believe, about a 60-watt wand, and it requires a base station. So when you're putting together a list of equipment that you need for doing soldering, some of the basic things that you would look for are soldering wick. So soldering wick is really good for removing excess solder around joints. So if you are working on a board or a hunk of wire that's got a lot of solder on it that you can't get off, this will wick away the solder around the joint to make it easier to either remove the component from a board if it's through hole, or remove excess solder in a wire bunch if you're trying to remove the solder off that. It's not that expensive to get. You can get it from your electronics hobby shop or DigiKey or Mauser or any of those large electronics distributors. Another item that's really important to have is flux. And the rule of thumb is you never can have too much flux, especially with lead-free solder. Lead-free solder is a very difficult solder to work with as soon as it begins to oxidize. So again, this is something that can be purchased from electronic wholesale distributors. It's relatively inexpensive. You can probably also get this from your local hardware shops as well. But I have a preference for this type of flux in that it's more of a gel that stays in place. You can get liquid flux, but it tends to flow all over the place, and where you need it to stay, it doesn't like to stay. So my recommendation is stick with the gel, no clean flux for lead-free. So the next thing we need is solder. Now solder that you can get, you have two options. You stick with the lead-free. There's various alloys that have different performance characteristics. Lead-free solder, as I said, is not the easiest stuff to work with because it doesn't flow really well without good flux. Leaded solder is not very environmentally friendly. However, it does give you the best joint. So if you are doing this for personal home use, lead-free will work. Lead will work. The issue with leaded is that obviously it's a toxin, and if you're working with it, you need to make sure you clean your hands really well afterwards. But as I said, it will give you the best solder joint and the most reliable solder joint. One of the problems in the industry with the lead-free is that if you leave the lead-free alloy exposed to the environment, what can happen is with the term tin whiskering, which is basically the tin out of the alloy forming a little crystalline thread. And this little hair thread is conductive, and it can cause shorts on boards. Now, it's not a big problem when you have a lot of current behind there to burn off that little filament, but when you have very high impedance circuits where there's very little current flow, they can tend to short the signal, and then it's a brutal thing to try and track down as to where that problem is. So, it's up to the person who is doing the work as to whether they want to use leaded or unleaded solder. A pair of tweezers. Now, this is most important for working with any surface mount type components or any tiny components that you're trying to solder. Through-hole, it still is useful for through-hole components like through-hole resistors, but a nice little set of tweezers, you can usually get them from surplus stores, and in this case these are actually intended for electronics. They will aid greatly when you're trying to solder very small components down. Probably the next thing that you'd be looking for is a pair of pliers or side cutters, I guess. Now, those are pretty common for electronics. So what's really handy is having a small set of needle nose pliers and a small set of side cutters that are intended for very fine cuts. And again, these can be purchased from your electronic wholesalers or from your local hobby shops or hardware stores. So they're not that hard to get a hold of. Mine are in various shapes because they've been used and well abused for many years. And again, it's worth the investment to purchase something like that. So with all this would give you the basics for doing any small rework at home, and having a pretty good success at ensuring that you get a proper solder joint when you do the repair or change out of components. Okay, so now I'm just going to do a simple soldering of a through-hole resistor and just show you this really simple soldering technique. Now, with through-hole components, you want to make sure that the leads are not bent right up against the component. You want to leave a little bit of space so that you strain relief the end. That's where a good little set of pliers will make it really easy to do. Just going to insert it just about. So now the component's resting on the board. The leads are not stressing the terminations, and you just need to just pull the leads apart just slightly to hold it in place. Let's see here. We add our flux. So the trick is to add a bit of solder at the end of the tip of the soldering iron that's going to be in contact with the joint. This gives you a nice little puddle of solder to contact with the lead, and then you add a little bit extra in there and drag it off. So what that does is, what the puddle does is gives you a really good thermal contact with the lead versus a point contact that the soldering tip might do. So again, we add a little bit of solder to the tip, which will make it easier to contact the lead that we're trying to heat up. Contact the lead, add a little bit of solder, and drag it off. So what we should have, which I don't know if we can see or not, we should have a nice clean solder fillet on both those leads. And then you end up finishing off by trimming. And you don't want to trim too low. You want to leave a little bit of the lead there. And then that completes your solder joint. Now to remove that, we go back to using the solder wick that I mentioned earlier. And you know, it's pretty straightforward. This solder wick actually has flux, you know, woven into it. In my case, I always use a little bit extra of the gel flux, and I'll add it to that joint I'm going to be unsoldering. And with the solder flux, or sorry, the solder wick, I usually rest it on top of it and then heat up the solder wick and allow the solder to melt underneath and flow into the solder wick. So what it will do is remove all the solder from that joint. Provided my tip is clean. Now sometimes there'll still be a little bit of solder holding it in place, and you can just take your pliers and just give it a little jiggle wiggle, and then you can remove your resistor. Now after the resistor is gone, you can go back again with solder wick to clean up the holes, but in this case it's not necessary. Okay, so for soldering through-hole components onto a header, for the sake of it, one of the things, if I want to solder, let's say, to the two end solder tabs on this header, I would choose to have the leads far enough out away from the body and then bend it at the location where I want to solder. So if you see, we're pretty far away from the body, so we're not stressing the end terminations at all. And now I just want to trim it down to how far off of the header I want it to sit. So I want to sit somewhere around, you know, quarter or 3/16 of an inch or so above the header. Obviously this is not as easy to do when we're trying to film it. So add our solder flux to the solder tabs on the connector. Put solder pooled on the end of the tip so we have a good thermal conduction to the joint that we're going to be making. And actually we'll get our tweezers here so we don't burn our fingers. I'm making this way harder on myself because to get the angle for the camera, I was putting this off center from my body that I would normally have the vise off of, and yes, it's just making this real fun. So not the prettiest joints, but I mean, again, if I was doing this on my own, not on camera, this would be in front of my body where it's much easier to work on. But what you can see is that the joints themselves are nice and shiny, so that means that there's no cold solder joints. And there's enough solder on there that it's not going to break off. So you can have different ways of doing this, but again, you don't want anything that's dull metal there. You want it shiny, and once you've done your solder joint, you can use some alcohol to clean off the no clean flux. You know, they say no clean, but it still leaves a sticky residue. So that's how you would do a resistor on a header. Okay, let's talk about surface mount a little bit. Surface mount is pretty easy to work with, except when it's really small. So what is small? 0201, that's way too small to be working with without a microscope. So that's a really tiny component size. 1206, which is equivalent to that size. That's pretty easy to work with. SO8 packages, again, not too bad to work with. So if you're a home hobbyist, you know, something like this is pretty easy to work with. Again, it requires having the right soldering equipment, however, right size tips, and lots of flux. So I'm just going to do a really simple soldering of an SO8 and a 1206 resistor. So this is some generic IC that I've got hanging around the lab here. So again, flux, lots of flux. Obviously you don't want so much that it's going to make working with this difficult. So you want to be able to line up the pads and the leads of the component. So I'm just going to pull this out of frame for a second. Again, obviously this is much harder to do when you're filming this versus doing it in front of you. So with the flux on the pads, with the leads of the component, you just need to gently hold down the component and touch one of the leads to solder it to the pad, and then touch another one that's opposite, so that this then pins the component down, and you can continue with soldering the rest of the leads without worrying about dislodging the component. So I'm just going to hold it down, touch, touch. So now I've got that component soldered down on two leads, and it's not going to move around anywhere. So the rest of it is pretty straightforward. Again, this tip size is a little bit big for doing this job. Ideally you'd want something a little bit smaller, more along the lines of something like that size. Oops. Versus that size. So you can see there's quite a bit of difference between the two. So again, I'm going to pool a little bit of solder. So this you have to be more careful with when you've got a larger soldering tip like this on small components. And you're just going to go down, and then you're just going to gently sweep the lead. actually have a little bit too much solder on there, and what you can do is take your flux, go over the leads, and then come back over with your soldering iron and just brush it. And because this doesn't have solder mask on it, so that's sort of the greenish, or sometimes it'll be black or a different color, the solder that I was putting onto the leads is going and flowing across the unexposed or the exposed copper, that is, and it's flowing into the pads that I don't want it to go to. So then I take my solder wick. Obviously you need to trim off the stuff that you've used previously, and you come over it, and then you can just clean up the edges. So now you've got a nice clean joint, which you can't really see very well on this. Soldering a 1206 resistor, again, pretty straightforward. Let's get this device set up right here. The all-important flux. Now these guys, I believe, are spaced for 1206, I think, on pads closest to the SO8 IC. Just going to double check here. Yeah, it's pretty close. So now I'm going to add my flux to the pads. Put a little bit of pool on the solder on the tip. Gently hold the resistor on the pads centered, and then you just come along with your pool of solder and just go touch to the end. Once it's in place, you can come to the other side and do the same thing. Touch the end. And again, that should be bright shiny joints. If you see a hazy joint, there's a possibility that it might be a cold solder joint. It might break. Again, I'll take a closer shot of that with the microscope so you can see. So I'm going to put on one more 1206, and I'll show you the technique for removing them if you're on an actual PCB board. So that one's on. So if you have to remove a surface mount resistor, there's a couple ways of doing it. The easiest is if you have an actual dedicated tool for removing it, and that's a set of heated tweezers. Most people will not have that in their homes. The second way you can do it is if you have two soldering irons. So two soldering irons will allow you to come in from different sides of the package. So in this case, you'd come in on either side and heat simultaneously both sides of the resistor, and then you'll be able to just pop it off. If you only have one soldering iron, the other way you can do it is to quickly, add enough solder to the edge of the package, like to the leads of the package, so you're actually having more than what you need. And the reason this is important is because you need to have thermal mass there that will keep it liquid, or in a liquid state, because you're going to quickly go back and forth and heat both sides up. And then you just kick it off. Oops, I just resoldered it. If you didn't have enough solder to hold the heat, what can happen is that as soon as you unsolder or get the solder to go into a liquid form on one side and you kick over to the other side, it will solidify too quickly, and then you won't be able to kick it off the pad. The second thing though that can happen is if there's any vias that go down into ground planes, and that will make it really hard without a lot of solder in place to heat both sides up to the point that you can kick the resistor off. If you're working with ceramic capacitors, you have to handle those with more care. In the case of the resistors, they're pretty tough. You still can crack them, but they're pretty tough. With a ceramic capacitor, if you're putting a ceramic capacitor down, you need to really be careful to reflow both sides simultaneously, because what ends up happening is if you solder one side and then you go to the other side, you set up a stress in the component, which can shear off the end termination. So again, it's just something to be careful about. If you don't have hot air, or you don't have two soldering irons that allow you to reflow both terminations at the same time, then you are probably going to run into a long-term failure if only one joint is soldered at a time. So again, just something to be aware of. Anyway, so this is a really basic, how do you solder type video, and obviously there's many better videos out there for doing this. The key thing is use the flux, pool your solder onto the tip of your soldering iron before you try to heat up the joint that you're going to heat up. This again will give you a better thermal contact to the joint versus just having a point contact that you'd get from the soldering iron. When you're all done, inspect your joints with a magnifying glass if it's small surface mount components, and make sure you don't have any solder bridges or cold solder joints. If your joints are not nice and shiny, go back over it with flux and reflow the component, or reflow the leads that don't have nice shiny I guess solder showing. Use lead-free where you can. Try to avoid lead just because it's not environmentally friendly and it's more toxic, and you have to be more careful about handling it. If you can't use lead-free, lead solder will work really well. It's much easier to flow in a solder joint. However, you do have to be careful with the handling of it.